right, we're looking at lesson 2.1, and we're going to be talking about functions and relations in this lesson. So first of all, the definition of a relation is it's a set of pairs of inputs and outputs, and we can express relations in different ways. First, we can use ordered pairs, so your inputs and your outputs. We put the input first, which is typically your x coordinate, and then we put the output next, which is our y coordinate. So we have -3, 4 for the first ordered pair. We can also do a mapping diagram, and so we have -3 goes to 4 here, the inputs and the outputs. We also, in the ordered pairs, we have 3 goes to -1. So then in the mapping, we just have 3 and an arrow to -1. With the ordered pair, we have 4 goes to -1 and 4 goes to 3. So then we just list the 4 one time, and we would draw an arrow to -1 and to 3. We can also put these ordered pairs onto a table of values, which I call an XY chart. So we have the ordered pair -3, 4, so the input's -3, the output's 4. And then lastly, we can graph our ordered pairs, or our inputs and outputs. So at -3, your input -3, your Y value, your output would be 4. Now here's an example. It says the monthly average water temperature of the Gulf of Mexico in Key West, Florida varies during the year. In January, the average water temp is 69 degrees. In February, it's 70 degrees. In March, it's 75. And in April, it's 78 degrees. How can you represent this relation in 4 different ways? Well, we could use mapping. And so in January, it is 69 degrees. In February, it is 70 degrees. In March, it is 75 degrees. And in April, it's 78 degrees. Now, if we were going to put these values onto a table, January is the first month. So let's do an XY chart here. Let me erase here real quick like. So the inputs are the X's, the outputs are the Y's. So our input is January. That's the first month, so we'll put a 1 there. And the temperature is 69. February is the second month, and it's 70. March is the third month, and it's 75. And April is the fourth month, and it's 78. Now, if we write these as ordered pairs, you would have 1, 69, the X's, and then the Y's. It's in alphabetical order. And 375 and 478. Lastly, we can graph these. Now let's see, our x-axis, we will count by ones. And on the y-axis, those are larger numbers, so let's count by tens. And then we can just plot these points. So at 1, we're at 69. So just about 70. My pen's fat, so it should be a little bit underneath 70. At 2, we're at 70. At 3, the third month, it's 75. And the fourth month, it's 78. So when we have relations, the domain of a relation is the set of inputs. So when we say domain, we're talking about the inputs, and those are referred to as your x coordinates also when you're looking at an ordered pair. The range is the set of outputs, also called the y coordinates of an ordered pair. So you have domain and range. So the domain would be your x values, your range would be the y's. And I always think DR as in doctor, domain comes first and then the range. So in this next problem, it says, what are the domain and range of the relation? And so we'll use set notation to write out our answer. The domain would be the x values. And when we use set notation, we want to use brackets. And we want to list all of the x values, the domain, and we want them to be in numerical order, and we don't repeat them. Even if they're repeated, we don't repeat them in our list for the domain. So we have -3, 0, 2, 9, 23, which those are in numerical order already. And the range would be the y values. And again, let's see, we have 14, let me use a different color here. 14, 7, 0, negative 18, negative 99. They're not in order. We need to start with the smallest number. So we'll start with negative 99, and then it's negative 18, 0, 7, and 14. That would be the list of numbers in the range. So next we're going to talk about functions. A function is a special type of relation in which each element of the domain corresponds with exactly one element of the range. Every input has exactly one output in order to be a function. So to help us understand this, I brought in some function machines that you probably used in elementary school where you have a rule. Let's say it's x plus 4. And if the input in this case, let's say the input was 2, the output would be 2 plus 4 is 6. And we're going to put these on a table. So this is the input, and these will be the output. So if we put in a 2, out comes a 6. Now let's say that we put in a 3, the output would be 7. If we put in a negative 3, the output would be 1. Now, if we were to put in, say for example, a 2, and this time the output came out as like a 10, well, 2 plus 4 is not 10. And so if you have, with a function, if you have an input, it can only have one output. So in this case, it could not be a function if that was the case. So the only output possible with this function for 2 is 6. So that would not be possible. All right, so let's look at another example here. If your rule is the absolute value of x, and let's make an xy chart and look at some possibilities here. If we put in a 3, take the absolute value of 3, you get 3. And we did that correctly. If we put in a 4, the absolute value of 4 is 4. Now, if we put in a negative 4, what's the absolute value of negative 4? Well, that's a positive 4 also. So as you can see, the y values are repeated, but we did it correctly. So 4 has only one output. There's only one answer you can get, and negative 4 will only give you one answer, one output. So you'll notice in our list, to be a function, your x's cannot be repeated, but your y's can be repeated. Here are some more examples of functions. So here we have a mapping that's displaying a function. Negative 3 has exactly one output. Negative 2 only goes one place. Negative 1 only goes one place. 0 only gives you one output, and 1 only gives you one output. Here's another example. In all of these numbers, you only have one output. Here's another example. Look at all of your inputs. They're different, and they all have just one output. Now in this example, 4 is your input and it's giving you an output of 12. But in the next ordered pair, 4 is giving you an output of 15. It can't have two different outputs. So this is not a function. 5 also has two different outputs, and so it is not a function. So these would be examples of not a function. So let's look at some more examples. This is the relation a function? Well, negative 3 has one output, 0 has one output, 4 has one output. So we'd say yes. In this next example, 2 is giving you two different outputs, and so we would say no. Because 2 is going to negative 3, and we could write 2 again and say that it's going to positive 3. So 2 is getting repeated in the domain. In the next example, if we look at the inputs, we see 4 repeated here in the x's, and it's giving you two different outputs, and it can only have one, so you would say no, this is not a function. In the next example, look at your domain. All of those numbers are different, and so we would say yes. They each go to one output. Now I just want to show you the vertical line test. It's a relation is a function if a vertical line drawn does not pass through more than one point on the graph. Now this is an example we looked at in the first screen where 4 went to -1 and 4 went to 1. I'm just going to graph those points. So if we're at 4, -1, that's right here. And then 4, 1 is right here. You'll notice we said this is not a function because 4 is going here and 4 is going here. Those points are in a vertical line. So anytime you can draw a vertical line through a function and if it hits more than one point, that line does, you know you don't have a function. Now in this example, if you draw a vertical line, you only hit once. Here, you only hit once. Anywhere on this graph, if we draw a vertical line, if you only hit once, it would be a function. In this next example, if we draw a vertical line, oh, it has a value here and here. We hit 2 places, so this is not a function. So for example, this might be like a -3. -3 would have an output up here, and -3 would have an output down here. So that's not a function. If we draw a vertical line, oh, we hit 2 places, not a function. If we draw vertical lines on this graph, if I can draw them straight, I'll try, only hit the graph, every line only hits once, so we would say yes. Here, if we draw some vertical lines, they only hit the graph one time. So again, this is a function. All right, now we're going to talk about function notation. Now, a linear function can be written in the form of y equals mx plus b. We call that slope-intercept form, where this is your slope and this is your y-intercept. So if you have y equals 3x plus 2, that's in slope-intercept form. Well, function notation would take that, and instead of writing y, it writes f of x. So the function's value when x is equal to something equals 3x plus 2. So when you see f of x, think, oh, that's like a y. It's just like a y. You could write a y right here. So let's show you how that works. So for the function f of x equals -4x plus 1, what is the output for the given input? So when your input, which is your x, is equal to a -2, the way we would write that is f of -2 equals -4. And what does x equal? So what we do is we substitute in that input in for the x. When we're working with function notation, we only work on the right side of the equation and simplify that. So that would be 8 plus 1, which is 9. So the function's value when x is a -2 equals 9. Now let's take a look at if we did when x is equal to 0. So the function's value when x is 0, so we have to substitute 0 in for the x here, would be 0 plus 1, which is 1. So the function's value when x is 0 is equal to 1. This is like the output. This is the input. Oops, I said that wrong. This x right here, this is your input, and this is the output. Sorry about that. So this is your x, this is your y. And we'll do one more here. The function's value when x is 5 would be -4 times 5 plus 1. So that's -20 plus 1, which is -19. So the function's value when x is 5 equals -19. I just want to show you this function if we were to graph it. So the y-intercept of that is 1, and the slope is -4 over 1. So down 4 over 1. Or up 4, back 1. And if we draw a line here, not the straightest line ever, but looking at this, it says when x is -2, so your input is -2, what's your y value? Oh, it's at 9. When x is 0, what's your y value? It's at 1. When x is 5, your y value is way down here at -19. And that's the end of this lesson. Please see me if you have questions.